Hello, 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 my ninja warriors. What's up, everybody? How is everybody doing? I know I am 8 minutes late, and you guys were talking about Ninja Ma'am is going to cancel the session. No, I am not going to do that, okay? Because I am here to teach you complex numbers. How ready are we to study this chapter? Do let me know in the chat box, okay? Because this chapter is something which I have not taught. What's happening? Let me just fix this view for you, okay? So it should go like this. Oh, no, it should not look like this. Oh, you can see my studio also. Ah, hmm. Better? Better now? Better now? Yes. Okay. All right, everybody, just give me a green signal that, ma'am, you are absolutely audible as well as visible. You guys are not telling me. Good evening. Yes, I saw one good evening, Surya. How are you? How is everybody doing? Am I audible? Am I visible? Give me a green signal. Yes, everyone. Okay, now today we are going to start a new chapter. A new chapter, and you know what? This chapter we are going to start from absolute basic. Because why I'm saying this? Because so many students get scared from this chapter. How many of you are scared of this chapter? This is what you tell me, huh? This is what you people tell me that, ma'am, we are scared of this chapter. One student is saying, good night, madam. Good night. Then why are you here? Just go and sleep. Have a good night. Okay. All right. Okay. So let me set the agenda. Complex numbers, if I talk about this chapter, one short question you will get from this chapter. Okay. And you know what? If you see your NCRT level chapter, this session is going to be approximately 2 hours. Okay. So if you gonna see your NCRT of complex numbers, things will be pretty much easy. Your complex numbers will All right, I hope I am audible now. Yes. After so much different session, ma'am has different appearance. Is it? Is it what you think about this thing? Yeah. Audible now, everybody? Please confirm. Okay, we are going to start. We are going to start complex numbers from the very basics. Okay. Now, please understand this is not a fast track session. Like, ma'am, please quickly teach me fast, ma'am. No, we are going to dive a little deeper in this chapter. So make sure that you are not rushing, and we are not going to finish the chapter with in this session only. Okay, we are going to come tomorrow and we are going to redo this chapter. Okay, everybody. And also, if any, especially 2027 aspirants, you know what, I know that 2026 aspirants are in a little hurry that, ma'am, teach me this, teach me that. But if I talk about 2027 aspirants, you people have time to dive deeper and get ready for any kind of question from this chapter. Okay, yes. Now let's quickly start the chapter. Let's start with imaginary numbers. Okay, imaginary number. Where does this concept of imaginary thing, iota thing, came into the picture, that I am going to tell you. So we are going to start with that basic. We are going to start with the history of this chapter a little bit also. Okay, ma'am, your voice is padding. Is it is it very irritating you, my voice? If you can tell me, I can actually yeah, I think it will be, it is a little better now. Please confirm. Is it a little better? Okay. So imaginary numbers, right? The mathematician Rene. Okay, Rene. Imagine according to this mathematician Rene. Okay. Rene says that imaginary number is a number whose square is a real number that is not positive. Basically, what they are saying is square of an imaginary number. Let us suppose I say that my imaginary number is I. Let us suppose I say that my imaginary number is denoted by I. Okay, right? Now, as per this mathematician, he says that square of any imaginary number is negative. Square of any imaginary number is negative, my dear students. Okay, all right. So iota square, we represent it by iota. Iota square is -1, or you can say iota is nothing but square root of -1. This is the origin of, what do we say, origin of complex numbers, right? Okay. Now let me talk about this equation, which is very popular. X square plus 16 is equals to 0. Correct? Let's try to solve this equation. Let's try to understand that from where exactly on the very first place we saw that, oh, where is this iota is coming from, or where is this requirement of a square of number being negative. Okay, randomly, how do you think that, ma'am, square of a number will be negative? Why are you thinking in that direction? Because of this equation. This equation is going to tell you the requirement of this chapter. Why actually we need to study complex number, or complex numbers exist in the very first place. Okay. Yes, William. But definite integration to I have already done, William. What are you doing? Go and watch JEE Booster mein. I have finished it. Okay. So this is going to be x square plus 16 is equals to 0. That means x square will be minus 16. Correct? X square being minus 16 means what? The square will go from here and you will have to apply a square root. So x will be square root of minus 16 plus minus sign, because you remove square. So you have to apply plus minus sign also. Okay. And then the moment you see that, understand this minus 16 can be written down as 16 into minus 1. And eventually what happened, you have to just write plus minus root 16 and root minus 1. Root 16 is 4 and this is iota, so plus minus 4 iota, if you can see that x is coming out as plus minus 4 iota. So that is why we need to know the significance or the importance. We need to actually talk about square root of minus 1. If you are not going to talk about square root of minus 1, then how will you solve these type of equations? Okay. Yes, everyone? Getting it little? Okay. So now we are going to talk about the integral powers of iota. Powers of iota is so important. We all know now that iota is nothing but square root of minus 1. Everybody? Now you know. Now tell me what will be iota square. So iota square would be minus 1, my dear students. Iota square is nothing but minus 1. Okay. All right. I don't know. You guys are not talking in English, right? Huh? And you're talking something. Board low, easy kani, main slow, road chapter. Santosh, everybody is talking about this class only. Nobody is talking in English. Huh? What happened? And I can't understand the language. Hmm? You guys are not talking to me. You guys are talking among yourselves. Is it? Anyway, come back. Iota square. Iota square over here is nothing but minus 1, correct? So basically here what we are going to do is we are going to decode the powers of iota. I mean, we want to experiment that iota power 1 is something, iota power 2, iota power 3, 4, 5, 6, 7, 8, 9, 10 and so on, right? Okay. So iota square is minus 1. Now one more thing. If I multiply iota on both the sides, let's multiply iota on both the sides. What will you get? Iota cube is nothing but minus iota. Iota cube is nothing but minus iota, my dear students. Okay. And iota power 4 is nothing but what? Iota power 4. Can you see if you square this? Okay, I am back. So this is how it is. Okay. So now we know that the cycle, what kind of cycle is going to be. Now understand. Iota power 4. See, iota power 4 clearly is 1. Correct. So iota power 8 will also be 1. Iota power 12 will also be 1. So basically iota power multiple of 4 will be 1. Okay. So whenever you see powers of iota, what you're going to do is think about the power of iota in terms of table of 4. Okay. So iota power 4, 8, 12. Now iota power 5, everybody. Now iota power 5 is iota only. So iota power 1, iota power 5, iota power 9. Basically 1 more than multiple of 4. 1 more than multiple of 4 is going to be just iota. Okay. Now 2 more than multiple of 4. So iota square, iota power 6, iota power 10. Can you see 2 more than multiple of 4 is going to be minus 1 and 3 more than multiple. So iota cube, this is iota cube, or you can say that it is going to be iota power 7, or it is going to be iota power 11. Basically 3 more than multiple of 4. Okay, all right. Y is not equal to root minus 1 in algebra manipulation. I am not understanding what your doubt is. It is not clear. Okay, your doubt is not clear. Otherwise, I would have responded. Okay, so now understand that iota power 4n is one multiple of 4. When the power is multiple of 4, when the power is multiple of 4 plus 1, power is multiple of 4 plus 2, power is multiple of 4 plus 3. Correct? Now, if you add okay, so let's solve this question now. Sigma. How many of you are actually scared of sigma? That ma'am, I to absolutely am scared of sigma. So please do not get scared of. Open the sigma. What is sigma? So basically this is sigma iota power n plus sigma iota power n plus 1. Here n starts with 1 to 13 and n starts with 1 to 13. Okay. So if you start, it is iota power 1 plus iota power 2 plus iota power 3 and so on iota power 30. Correct? Okay. When we start from here, yes. Yes. Now iota power 1 plus 1. So it starts with iota square, iota cube. Eventually keep on progressing. Last you have to put iota power 13 plus 1. So iota power 14. Okay. So clearly now I think it is going to be very useful. What is happening? No. What is happening? Okay. Now understand. Sometimes this digital board runs on its own. I have no say about it. See, you know, sometimes we listen to that news that AI is going to be dangerous for us. It will do on its things on its own, and it can destroy humanity also, human civilization also. Robots will come. Have you watched that robot movie of Rajnikant? Same thing. Same thing is happening with me. I want my digital board to work according to me, but then someday some random thing happens and the whole hard work, whole notes will get destroyed. What is this behavior? What is this behavior? Digital board, please don't do that. The more AI we are going to add on it, the more automatic it will run on its own. Okay. See now, see what I was telling you is that information, that piece of information, that consecutive powers of iota, 4 consecutive powers of iota will give you 0. So clearly that if I start with 1, 1, 2, 3, 4 will be 0. 1, 2, 3, 4 will be 0. Then 5, 6, 7, 8 will be 0. 9, 10, 11, 12 will be 0. So this will be iota power just 13 plus. Now from here again, Iota square. So it starts with iota square. So 2, 3, 4, 5, 0. 2, 3, 4, 5. 6, 7, 8, 9, 0. Correct? Basically, the last term will be left out term. Okay, so now iota power 13, everybody, iota power 13 is iota power 12 iota plus iota power 14 will be what? It is going to be iota power 12 iota square. Iota power 12 is anyway 1 because iota power 12 is multiple of 4. So this is 1. So this is iota plus iota square. So the answer will be iota minus 1. Yes? Tell me. Solve this question. Solve this question now. Okay. All right. Okay. So again, it looks like it is a quadratic equation. Do you remember the formula of quadratic equation, everybody? So easy, right? So x is going to be minus b plus minus square root of b square minus 4ac upon 2a. Okay. So x is nothing but minus iota plus minus square root of minus 1. So minus 49. Okay, upon 2. So clearly it will be minus iota plus minus 7 iota by 2. Okay. So now 7 minus 1, this is 6 iota by 2. And this is going to be minus minus, so minus 4 iota. Correct. So 3 iota and minus 4 iota is your answer. Everybody? Yes? 3 iota and minus 4 iota. Perfecto. Absolutely. Okay. Let's move on to the next question. Now I am curious, how many of you can actually solve this question, everyone? Yes. Yes, Louis. Absolutely right. Okay. I can see some people are saying 0. Let's see. Iota power 535. Now understand, I told you what you have to do is this 535, right? 35. You need to think about multiple of 4. And I hope you all know that multiple of 4 is something whose last 2 digits is divisible by 4. Here right now it is 35. And we all know that 532, because 32 is divisible by 4, na? 532 plus 3, correct? This is the power. So this is iota power 532 and iota power 3 plus 1 upon. Can you see if I multiply iota and iota on numerator and denominator? So it will be much more easier for me. So right now this is going to be 1. This is also going to be 1. Iota cube plus iota is the answer. Iota cube is minus iota plus iota. A lot of you are absolutely right. 0 is absolutely correct answer. Okay. All right, everyone. Yes, clear. Okay. Let's now introduce the complex numbers. Okay. Let's now introduce the complex numbers. Please understand, iota is not a the iota is a complex number, but I mean the moment you see iota, please don't just say that, oh, iota means complex number. No. You know what? Can anybody tell me that 2 is 2 a complex numbers in the chat box? 2, number 2. Number 2, is it a complex number, everyone? Is it a complex number? 2 is a complex number, my students. Okay. Ma'am, ignoring me? No, I am not ignoring anybody. Why would I do that? Okay. So 2 is a complex number, right? So please understand the definition of complex number. A complex number of the form a plus iota b is known as complex number, where a comma b belongs to real number. Okay. So a and b are real. Here a and b can't be imaginary because iota itself is placed to make this imaginary thing. Okay. So z is equals to a plus iota b. A is real part of z, that's how we write, and b is imaginary part of z. So a complex number of the type a plus iota b is going to give you real and imaginary part of z. Okay, all right, yes. So, okay, all right. Now let's note down some important things about complex number, and this is going to be absolutely basic of complex number. Everybody should be aware about it. Okay. The first thing is z is equals to a plus iota b if at all b is 0. B is 0. Okay, that means suppose z is equals to 2 plus 0 iota. So b is 0. Correct. So this is a purely real complex number. This will be called as when the imaginary part is 0, na, basically. When the imaginary part is 0, that means what? That complex number is purely real. Now, if at all the a is 0, okay, then it is going to be purely imaginary. That means if real part is 0, then it is purely imaginary. Okay. Now, interesting thing, very important. Nobody is going to tell you. You have to think it for yourself. 0 is a complex number because it can be represented as 0 plus 0 iota. Interesting point that its real part is also 0 and its imaginary part is also 0, right? Okay, so that means 0 is the only complex number in this entire planet, universe, you can say. Okay, so purely real as well as purely imaginary. 0 is purely real as well as purely imaginary. Okay, a number which is purely real. Yes, it is purely real. Is it purely imaginary? Yes, absolutely purely imaginary. Yes, Rohit, I can see you. 50% of your concept are clear. Go for part test. 70% go for full test. Okay, yes. All right. Now one more thing. The complete number system I want you all to see. Natural number is what? 1, 2, 3 and so on. Natural number is subset of whole number. Whole number is 0, 1, 2, 3 and so on. Integer is plus minus 1, plus minus 2 and 0, so on. This is rational number, this is real number, and this is nothing but complex number. Okay, complex numbers. All right. Yes. Okay. Now minus 2 iota. Minus 2 iota is something which is purely imaginary. We can see why? Because the real part is 0. 5 is purely real because the imaginary part is what? 0, correct? Now minus 9 ka root. It is nothing but 3 iota. 3 iota purely imaginary number, everybody. Yes. And root x. Okay. So yes, I don't think so that this is something which is, it is quite obvious. Okay. Oh, all right. Okay. Now let's talk about every real number, a complex number. Yes, absolutely, Rohit Kumar. Now understand. Two complex numbers are said to be equal when their real part is equal and their imaginary part is equal. Okay. Suppose this is c plus iota d. Correct. So if you are saying z1 and z2 are equal, a is equals to c and b is equals to d. A is equals to c and b is equals to d. Okay. So here real part are equal and imaginary part are also equal. Okay. I will give you one question now. Time for a question, everybody, and tell me the answers. Okay. Let's solve this question now. I think it is pretty easy. If these two complex numbers are equal, then the real part, can you see 4x and 3 will be equal. And imaginary part 3x minus y should be equals to what? Minus 6. Okay. So clearly from here x is equals to 3 by 4, and if you put value over here, so 9 by 4 minus y is equals to 6. This will give you 9 by 4 minus 6 is equals to y. Okay. So 9 minus 24. 9 minus 24. It is 15 by 4. Yes. With a negative sign. Is your y correct? Okay. Yes, Rohit. See, your name is also not there. So I can't find your message in this so much thing. But anyway, you were asking about if you have lost last couple of days in JEE Main. What I was telling you is do not worry, because I am going to post a video tomorrow, okay, on exactly what to do. Exactly what to do in the last 45 days and how to come back. Okay, it is going to be reality check video. You can say that okay, it is going to be some motivation also. Okay, but so it is very crisp video, but the action plan, no, basically no BS. Okay. Yes. Yes, one student was asking, Sham was asking, ma'am, is it true that you have worked in Kota before joining Vedantu? Yes, absolutely yes. I have actually started my teaching journey with Kota only. Okay. And you know what? I have taught in one of the best institutes of Kota. The first ever institute of Kota. Okay. All right. Ma'am, why are your face looking so sad? Am I sad? I don't think so. Is it looking sad? But I'm just smiling all the time. Anyway. So 3x plus y is equals to minus 6. Correct? So this is minus 6. Absolutely. and 9 by 4 plus 6. Okay, 6 4s are 24 plus 9, so y will be what? 33 by 4. Yes. Okay, all right, easy peasy. Now we have spoken about equality of a complex numbers, right? Equality of complex numbers, but we haven't talked about inequality in complex number. Let me tell you, inequalities in complex number is meaningless. Okay, positive or negative complex numbers are not valid, basically, are not defined, meaningless. Now somebody will say, ma'am, no, then what is that triangle inequality? Understand, triangle inequality is always among the real numbers. Always you'll say mod of this greater than equals to mod of this less than equals to mod of this plus something like this. This particular format is triangle inequality, correct? So that is not complex number. They have taken modulus, which we are going to talk about in this session. What is modulus? But I'm just telling you that even if you see the inequality after this, you will be like, Ninja ma'am told no inequality in complex number. Array, no inequality in complex number chapter I am not saying. I am saying that you can't just say that 2 plus 3 iota is greater than 2 minus 3 iota. You can't say. Okay, you can't say this. Why? Because complex number is exactly like a coordinate. Can anybody tell me 1 comma 2 coordinate and 5 comma minus 3 coordinate, which one is greater? So you'll be like, huh, coordinate, greater less, so nothing happen in coordinate. Coordinate is just a point. It is just to denote a certain position, right? Okay, so you can't compare that which number is bigger and which number is smaller. Okay, now how do you add two complex numbers? Very easy, just add the real part a plus c, real part a plus c, and add the imaginary part b plus d and apply iota over here. Very easy. Subtraction again, just subtract the real part plus iota times subtract the imaginary part. Easy peasy. Multiplication again, just multiply these two things and one by one, a into c, then a into d times iota, then I b c, and then iota. Last two terms if you multiply, it will be iota square. Iota square is nothing but minus 1. So just accordingly you multiply, iota square will be minus 1. So iota square term, this is going to be a real term, minus bd. So hence AC minus BD will be the real part and iota times this cross connection will be there. Okay, and yes. Now let's do this question in the simplification format. Okay, simplify 1 plus iota and 1 minus upon 1 minus iota in the format of a plus iota b. So in these type of question we know how to rationalize the stuff. Okay, so clearly 1 plus iota whole upon 1 minus iota, and I want to represent it in this format. What I am going to do is I am going to multiply it with 1 plus iota and 1 plus iota. Okay, why? Because see, I am just changing the sign of iota over here. See, always rationalize the denominator by changing the sign of iota. Okay, so this is 1 minus iota, 1 plus iota. So a minus b, a plus b. So this is 1 square minus iota square. Okay, now what about this 1 plus iota whole square? Okay, so this is 1 plus iota square, so minus plus iota square plus 2 iota whole upon this is 1 plus 1 2. Clearly 1 and iota square is minus 1, so we can actually cancel these two terms. So this is 2 iota by iota, which is just iota. If you can remember it, it would be a good thing that 1 plus iota upon 1 minus iota is nothing but what? Iota only. Solve. I am waiting for you. 1 minus iota upon 1 plus iota. Solve. What are you going to get? Solve it. Okay, so if you solve it, you are going to get minus iota again. See, 1 minus iota upon 1 plus iota. Okay, if you rationalize it, you are going to multiply it with 1 minus iota upon 1 minus iota. Again, a plus b, a minus b is 2 only, right? 1 plus 1 minus iota square is what? Okay, 1 minus iota square is what? 2. And 1 plus iota square cancels. So this is going to be what? Minus 2 iota upon 2. So clearly this is minus iota. And you know what? Now I want all of you to remember certain things. Can you see we have just calculated these two things? 1 plus iota upon 1 minus iota. Whenever you see, remember. Try to remember. If not, then it's not a hard and fast thing. So this is iota, this is minus iota. 1 plus iota square is what? 2 iota. We just calculated it, by the way. And this is what? 1 minus iota square is minus 2 iota. By the way, one more thing. 1 upon iota is nothing but minus iota. Okay? Yes? Clear till now it is? Okay? Let me reload the next content. Okay? Okay, so let's do the JEE main PYQ now. Are we ready for a JEE main PYQ, everyone? Yes. These type of question, very easy questions. And you know what? We have not studied like much of a concepts from complex number, but still we can solve this question. Okay. So this question says that if this complex number is purely imaginary means what? Real part is 0. Okay, real part of complex number is 0. Okay, so real part of this is 0. And now what they are asking you is something. Okay, so real part is 0. One thing which I can say, real part is 0, correct? First of all, 3 plus 2 iota sine theta whole upon 1 minus 2 iota sine theta. Okay. Now, if you're going to rationalize 1 plus 2 iota sine theta upon 1 plus 2 iota sine theta. Okay. So, it is going to give you what? A minus b, a plus b is a square minus 4 iota sine square theta. And if you multiply, 3 ones are 3 plus 2 iota sine theta plus now this 6 iota sine theta minus 2 2s are 4 sine square theta. Okay, let me just show you this part of the board. Okay, clearly the denominator of this complex number iota square is what? Plus 1, sorry, minus 1. So this is the complex number, correct? Now you want this to be purely imaginary, that means real part should be 0. Can you see real part will be 3 minus 4 sine square theta upon something, okay, is equals to 0. So upon something has no significance over here. So 3 minus 4 sine square theta, clearly that sine theta is nothing but plus, or you can say that sine square theta is equal to what? Root 3 by 2 whole square. Sine square theta is nothing but root 3 by 2, which is 60 degree. Sine square pi by 3. Correct? Pi by 3. So, sum of elements in A. So, minus pi by 2 to pi, I think we have got our theta also. Minus pi by 2 to pi. Okay, let me draw the graph now. Minus pi by 2 to pi. So, clearly this is the graph and this is the minus pi by 2 thing. What we are looking at is that sine theta is being what? Root 3 by 2, correct? So, root 3 by 2 is at pi by 3. Pi minus pi by 3. Pi minus pi by 3. And over here, the negative quantity also minus pi by 3. That's it. Okay, 60 degree. So now, sum of the values, if you add this will be 0. Pi minus pi by 3 will be left out. Option D, 2 pi by 3 is absolutely correct. Okay? Yes? Have a look. Let me know. Alright. Geometric representation of a complex number is very important. Now we are actually diving into the real complex number, the core of a complex number, right? Okay. Okay. So complex number z is equals to a plus iota b can be represented by a unique point a comma b. As I told you also that why the inequality in complex number does not exist, because a comma b, the point over here, basically complex number is just a point. It's not a value. You can only compare the value, correct? So a comma b is the point P. Okay. Now it can be represented in an argand plane. This is argand plane. This is real axis. Okay. X axis is real axis and this is your imaginary axis. Okay. The rules are same just like your coordinate axis. 0 plus 0 iota, can you see, is lying over here, represent the origin, and any purely real number will lie on the real axis and only purely imaginary number will lie on the imaginary axis. Everybody, yes? See? Any purely real number represented by the point on the x-axis called real axis. So this is your real axis. Imaginary number 2 iota, so that means 0 comma 2 is the point, so that is the point, right? It will be imaginary axis and the overall plane is not called as coordinate plane because that was something Rohit, tomorrow you watch my video and it will change the overall game. I'm pretty sure. I'm pretty confident on that. Okay. All right. Yes. The place representing complex numbers are argand plane and complex plane. So this is your argand plane. This is your complex plane. Okay. All right. Ma'am, I didn't understand the pi minus pi by 3 array. You didn't understand. So go for 2 pi by 3. Tell me. Tell me na. 60 degree, sine 60 degree and sine 120 degree both are root 3 by 2. That's what it is. Okay. Basically, sine... Oof. This is so basic. This is class 10th grader will also tell you. Tell me, sine theta and sine pi minus theta are both same or not? Sine theta, sine pi minus theta. Same only, right? Reduction formula. Simple. Okay. Chalo. So this is one small exercise for all of those who are studying complex number for the very first time. You have to plot this point on the argand plane. I will actually plot 1 point only, or let's say 3 points I will plot, rest you can manage. 3 plus 4 iota, 1, 2, 3, 1, 2, 3, 4. So 3 plus 4 iota will be here, okay. And 5 iota will lie over here. This is 5 iota. Then 2 will be lying over here. So this is just 2, okay. That's it. Tuck, tuck, tuck. Done, done, done. Okay. Yes, so this is how you plot. Okay, now one very important terminology related to complex number is nothing but conjugate of a complex number. Okay, conjugate, ma'am, will complex number become vectors? Don't you think? I mean, see, if you are going to see that way that ma'am, complex number is behaving like a point, it is behaving like a locus, then vector also, what is happening? I am so not even understanding. Okay. So understand, since complex number is a point now, coordinate geometry is coming into the picture. You can apply vector laws also to this. No need to study. Okay, little we study, but you know what? If you're good in vector, then you can do that. That shifting thing, barter collaboration between complex numbers and vectors. Where complex number is only taking stuff from vector algebra. Complex number is the one who is taking stuff from straight lines chapter, coordinate geometry. Complex number who is taking stuff from algebra. Complex number is only taking and behaving like a king. Huh? This chapter is actually basically having less originality and taking stuff from all the chapters like ellipse also, parabola. At the end, every chapter might get involved in this. Okay, that's the like bigger game happening in JEE mathematics. Okay, yes. All right, now yes. Conjugate of a complex number, very simple. You just have to flip the sign of imaginary part, and this is denoted by z bar. Z and z bar. Z is a plus iota b, so z bar is a minus iota b. Okay. So now what I was telling you is conjugate of a complex number, you just have to flip the sign of imaginary part. Okay, that is one thing you have to understand. The second very important thing is, if you know where your z is, your z bar will be nothing but the image about x-axis. So can you see z bar is the reflection of z in the real axis. So if this is p, this will be q. If this is q, this will be p. Okay, now I am going to give you that, can you please solve these questions and let me know your answers quickly in the chat box. Okay, yes everyone. Ma'am, are these PYQs of JEE Main? Whenever we are doing JEE Main PYQ, it's already written on the question. Do not worry, huh? If it is not written, that means it is a concept building question, right? Okay, like this. These are not JEE Main PYQ. JEE Main will not ask Z is equals to 3 plus 4 iota. The conjugate you have to write Z bar is equals to 3 minus 4 iota. At least you should know that JEE Main always ask MCQ or numerical integer. They don't ask fill in the blanks type of question, right? Now this iota minus 5, everybody, this is something so many students make mistake. Minus iota minus 5, because always flip the sign of imaginary part. Okay, some people will be like, ma'am, iota plus 5. Okay, iota plus 5 is the wrong thing. Now this Z is equals to 5, so Z bar will always be 5 because there is no imaginary part. How to flip the sign of non-existent thing? Minus 2 iota will be plus 2 iota. Okay. Yes, everybody. Okie dokie. Now, the next thing. Next thing over here is properties of conjugate. Ma'am, can you please teach PYQs, please? PYQs, we are already studying in this chapter, Spider-Man. I don't know you are studying for JEE Main for the very first time or not, but you know what, to explain a concept I need to give you some basic questions. I can't just come, and this is not a practice session, right? This is a concept building session. So yes, we are doing PYQs. In fact, we have done the PYQ in this session only. But if you are asking, ma'am, please only do PYQ, so come back in practice session. Maybe you are looking for the practice session, maybe you don't want to study theory. Okay, and I have done a lot of practice sessions. Go and watch those sessions, only question session. So no teaching will be there. If you don't want to study, go there. But this is something which is, I have initially also told you that these sessions are going to be a detailed oriented session where teaching is the main focus rather than problem solving. Okay, yes, all right. Now, properties of conjugate. Z bar whole bar. That means you take conjugate one time, you take another time, what you're going to get is back to your original complex number Z. Okay. Now this is very interesting. Z plus Z bar. So now Z is x plus iota y. Z bar is x minus iota y. So it will be 2x or 2a. Basically 2a. We are dealing with a and b over here. Okay. So yes, can you see if you add these two, you're going to get 2a. So Z plus Z bar is 2 times real part of Z. Z minus Z bar is 2 iota imaginary part of Z. Okay. Z bar is nothing but what? Z bar. Now this is something which is very important. Hero property. Hero property. Hero property. Z bar is nothing but you multiply. So it will be what? A plus b, a minus b. A square minus b square. So a square minus iota square b square will be what? A square plus b square. And you know what? This is nothing but mod z square. By the way, I haven't taught you what is mod z, but keep that in mind that z bar is equals to mod z square. Very, very important property from the from conjugate. Very important. Like so many questions will be done using this property. Okay. And yes, z is equals to z bar. Right? Z is equals to Z bar. So basically, if you equate these two things, what will you get? A to ma'am are already equal. Now, if you equate these two things, so ma'am, B is equals to minus B. That means 2B is equals to 0. B is equals to 0. Okay. All right. So Z is purely real. So B is equals to 0 means what? Z is equals to purely real. Okay. So Z and Z bar if equal, understand, if a number is equal to, very important, these two last two, Z is equals to Z bar will be the condition of purely real number. This is actually could be a shortcut, direct. Okay, direct. If a complex number is purely real, you can directly apply this condition Z is equals to Z bar. And if it is a purely imaginary, Z plus Z bar is equals to 0. The last two are very, very important. Okay. Yes, everyone. Alrighty. A couple of more properties of conjugate. Okay. Z1 plus Z2 bar will be what? So basically, you can individualize this. Whole bar will be Z1 bar plus Z2 bar. Z1 minus Z2 bar will be Z1 bar minus Z2 bar. Z1, Z2 whole bar will be what? Z1 bar, Z2 bar. And you know what? This is Z power n whole bar. And you know what? Basically, conjugate and power can interchange. You can interchange. Basically, a plus iota b power n whole bar is there. What you can do is, first of all, take a plus iota b bar and then apply n. So this is a minus iota b power n, right? Like this. And multiplication also, division also, you can just separate the terms out. Okay. All right. Now, I will give you this question, everyone. I want all of you to solve it. Okay. Okay. X plus iota y power 5 is 4 plus 5 iota, correct? Y plus iota x is power 5 is what? This is what your question is, everyone. Okay, now this is a actually slightly tricky, very good question, tricky question. Okay, so right now, you know what? It would be a very bad decision if you think that I am going to open this and then compare and then do this. Okay, no. What we need to do is, first of all, taking conjugate both the sides. Take conjugate both the sides. So x plus iota y power 5 is equals to 4 plus 5 iota, and all you have to do is take conjugate both the sides. Okay. So now conjugate and power are interchangeable. So it will be, first I am going to take conjugate and then I am going to apply power, and this is what? 4 minus 5 iota. Okay. Now you'll be like, ma'am, ma'am, what is happening over here? X minus iota y power 5 is equals to 4 minus 5 iota. Okay. But ma'am, we are to looking for this. What are you doing? So what I'm going to do is, I am going to multiply iota inside this. Okay. So iota power 5 on the left hand side and iota power 5 on the right hand side. So this iota power 5 will be what? Iota x, and then iota will be plus iota square, sorry, minus iota square, right? Minus iota square y power 5. Okay, yes. Iota I have inserted inside, and what about this? Iota power 5 is what? Just iota. This is iota. So this is 4 iota minus 5 iota square. 4 iota plus 5 will be on the right hand side, and on the left hand side, can you see this is iota x plus y power 5, which is actually this. So the answer is what? 4 plus 4 iota plus 5. Yes, everyone, give me a big thumbs up if you've understood this. Okay, another question, another equation solving game on your screen. Hint I am going to give you. Hint is already there actually. Hint is already there. Z is equals to x plus iota y. Just put it and keep solving it. Okay. Is asking something, by the way, ma'am. When are you starting JPYQs? How many of you are aware of the morning sessions? Huh? How many of you are aware about the morning sessions? Morning 6 o'clock every day we are taking sessions. It started today itself. Okay. Chalo, let's see. Let's try to solve this question now. Okay. Z square is equals to Z bar. Okay. Z square. Z square is what? X plus iota y whole square is equals to Z bar. X minus iota y. Z bar is what? X minus iota y. You can take A and B also, but over here it is written. Okay. So x square minus y square plus 2xy iota is equals to x minus iota y. Okay, now compare, because the real part and imaginary part will be equal. So x square first. X square minus y square is x, and second 2xy is nothing but minus y. Okay. Yes, I think this particular second, by the way, these two should both be equal at the same time, right? See, this equation holds true when this equation holds true, correct? And this equation holds true when this equation holds true. And this equation holds true when the real part are equal, and there is an and compulsion over here, and the imaginary part is also equal, correct? So over here clearly that the second I am going to solve the second thing. The second thing is going to give me y is equals to 0, correct? Y cancel, and x is equals to or x is equals to minus half. Okay, so now we have two cases. First case, okay, when y is becoming 0, then what is happening to this equation? Let's see. If y is 0, then x square is equals to x. This implies x square is equals to x. So x is equals to what? 0, 1, correct? And if your x is equals to minus half, then what is happening with this equation x minus half? If I put, so this is 1 by 4 minus y square is equals to minus half. Y square will be what? 1 by 4 plus 1 by 2. And this is going to give you y square will be what? 3 by 4? 3 by 4. Okay. So 3 by 4. So y will be equals to plus minus root 3 by 2. Okay. So now clearly if y is 0, so first complex number is 0 plus 0 iota. Second complex number is 1 plus 0 iota. Third complex number is when minus 1 by 2 and plus minus root 3 by 2 iota. Okay, how many? 4. Third and fourth. So 4 complex numbers are satisfying this equation. Yes, 4 complex numbers. So this question they can give you in JEE Main, by the way. Now understand, this question they can give you in JEE Main and they will say how many complex numbers will satisfy this. Find the number of complex numbers satisfy this equation. Good question, right? Okay. Like very small question, Very hidden question, very like abstracted question. Decode, you have to decode this. Although not a very difficult question, basic question, doable question, right? Okay. So this is how it is. Uh, 4 complex numbers, 0 plus 0 iota, 1 plus 0 iota, and this and this, and one more way of writing this. These are the 4 solutions. Okay, give me a big thumbs up if you have understood this. Okay. Chalo, ready for another question? Let's see how many of you can do this. These two are conjugate of each other, okay? What does that mean? That take conjugate of this and you will get this, okay? So basically cos x minus iota sine 2x is equals to sine x plus iota cos 2x, okay? So this is going to be cos x plus iota sine 2x is equals to sine x plus iota cos 2x. So it is so obvious, cos and sine are equal. Sine 2x cos 2x is equal. What does that mean? That tan x is 1 and tan 2x is also 1. Tan x is 1, tan 2x is 1. Both should be true, correct? So tan x 1 and tan 2x 1. Okay. Tan x1 when x is equals to pi by 4, okay, right? And tan 2x is 1 when 2x is equals to, so basically, you know what, you will get no value of x. Option D is absolutely correct. No value of x will satisfy this. Tell me now, at what value of x both will be same? No value of x can give you that. If you put pi by 4, so it will be what? Tan pi. So see, if x is pi by 4, it will not satisfy. If x is, it will not satisfy the second equation, right? So please understand, sometimes because students, what do they think? That either this is equal or this is equal. So we need to take union. No, this is an intersection thing. I hope you understand. We have to take intersection, my dear students. Alrighty. Yes. Okay. Perfecto. Now let's come back to this thing, which is modulus of a complex number. Yes, Akka, somebody is saying Akka. What do you want? Huh? Anna, Akka. What are you doing in the chat box? Huh? What is Anna and Akka? Let me Google it, huh? What are you talking in the chat box? Sometimes I feel I don't know the language, so it's a good thing. And sometimes I feel, oh, it's the best thing. Sometimes I feel I should learn the language, huh? And then one student is andharu sudden hai. Huh? Thank God, one student is talking my language, which is okie dokie. Rest everybody is like Anna, Akka, andharu sudden. What are you writing? When will you complete this session? The session is about to be completed within half an hour. Okay. Ma'am, I am your fan. Ma'am, please what? Thank you for being a fan. But you know what? This is not the age to be a fan, and I am not even a celebrity. Okay. Yes. Now, if you're getting inspired by me or if you're understanding my teaching, so that's why I am here for. Okay. Tamil, ma'am, Tamil. Can there be conjugate for any real? Conjugate for any real? Thank you so much, Music Hub. Thank you so much. Ma'am, please tell advanced level problems. We have just started the chapter. Advanced level problems will only come when we know at least little itsy pitsy things of the chapter. Okay, chalo. Now modulus of a complex number. Modulus of a complex number. Z is equals to A plus iota B. Okay. So now the modulus is nothing but square root of A square plus B square. It is denoted by mod Z. Mod Z is square root of A square plus B square. Okay. So this is the formula. Very easy, na? Modulus means square root of A square plus B square. But you know what, modulus is more than a formula. Actually, there is a geometrical significance of a modulus that you need to know. Okay, what is this? So we already know that if a complex number is there, x plus iota y, it is existing in the argand plane and the point P is nothing but x comma y only. Now the modulus is nothing but distance of point P from the origin. Okay, this OP is representing your modulus. Distance of any complex number from origin is nothing but what? What do we say? Distance of complex number from the origin is nothing but square root of x square plus a square. Okay? Yes? Yes, everyone? Mod z represents the distance of z from the origin. Okay? Now, one very interesting thing, understand, when we say, now this is to something which is very helpful in JEE Main, and this is something, if you know it, that means you need your real complex number. This is beyond NCERT. Now, this is something which not many people know. Please understand this, and you know what? Some questions can be done by geometry by just pure 10 seconds, 5 seconds, if you understand the geometry. Okay? Is it the magnitude, ma'am? Magnitude nahi, modulus? Yeah, you can say that magnitude also. Okay? Now, suppose we saw that mod of z is nothing but mod z minus 0 is nothing but distance between z and origin. This thing represent, modulus represent distance. But what about this z1 and z2? Mod z1, z2 means what? It is nothing but distance between z1 and z2. Here P point is x1 comma y1, Q point is x2 y2, and PQ, everybody will be able to tell me, ma'am, x2 minus x1 whole square plus y2 minus y1 whole square. And if you talk about mod z, it is square root of x minus 0 square plus y minus 0 square. So purely distance. Now I think it is so obvious. The moment you will see this, you will be like, okay, I know this. Okay, one question I am giving it to you. Let's see how many of you can actually solve this question. Not a very difficult question, but a concept building question for sure. Ma'am, can mod also have conjugate? Huh? No, modulus is a real, basically, modulus is a number. Modulus is a distance. Okay. Alright. Now, z plus mod z. What is z? Can anybody tell me? Z is x plus iota y. What is mod z? Mod z is square root of x square plus y square. equals to 1 plus 7 iota. Now compare. Compare the real part. X plus square root of x square plus y square is 1. And now the imaginary part is y is equals to 7. The moment you get y is equals to 7, you have to put y is equals to 7 over here. So it is going to be square root of x square plus 49 is equals to 1 minus x. So this is x square plus 49 is equals to 1 plus x square minus 2x. Okay, x square cancel. 48 is equals to 2x, x is equals to 24. What are you looking for? Mod z square, x square plus y square is what you are looking for. So this is 1 square, y square is what? 49. Okay, not 1 square, 24 square. 24 square plus 49, 7 square, right? So this is nothing but 625. This is the final answer. Yes, everyone? All right. Okay. Clear this question? Now let's talk about properties of modulus. Okay. Properties of modulus, and we are going to involve conjugate also in this. Very good thing. Okay. See, this is the, I think this session is better than roar series also, because in roar series now, complex number a little bit, I rushed a little bit, okay, in roar series. So this is the most detailed one, especially in terms of basics. This session is going to be absolutely good session, okay? Yes. Now, z is x plus iota y, z bar is x minus iota y, correct? Now, if you take modulus of this and modulus of this, you will realize both are same. That means mod z and mod of z bar and mod of minus z all are same. Why? Because you know what? The distance of x comma y from the origin is equal to distance of x comma minus y from the origin, and is equals to distance of minus x comma minus y from the origin. All the distance are equal. So this is your z bar and minus z. So modulus of all the three things will be equal. This is the very first thing. Okay. Now one more thing. I think this is quite obvious. Then if a complex number is 0 plus 0 iota, that means this complex number is actually sitting on the origin. Now distance of this point from the origin, from itself only, is 0. So mod z is equals to 0 means what? Mod z is equals to 0 means clearly the z is 0 plus 0 iota only. Only complex number whose distance is 0, okay? Now one hero property which I already told you, this particular property is going to blue complex number whole chapter, which is z bar is equals to mod z square, okay? Z bar is equals to mod z square. So this I have already told you. Now I know, I was telling you z bar was what? A square plus b square or x square plus y square. That is nothing but mod z square. Okay? Yes. Alright. And this is something which is very important. If mod z is given as 1, then z bar is nothing but 1 by z. Same, basically the special case of this hero property. Okay? Alright. Now property of modulus also says that if z1, z2 mod is there, you can separate out the modulus. And again, the same conjugate property, similar thing is happening. If power is there, you can actually apply the power later, and first you take the modulus. Modulus and power interchangeable, and in division also you can separate out the things, okay? Now this is one question which is very important. What is happening? Is there any mosquito over here? Yes. So this is going to the second last question of the day. Okay, I think 2 more questions and we are going to wrap up today's session. Very good session, I would say. Okay, yes. So now what they are saying is mod z1, mod z2, mod z3 all are equal, and which is equal to 1. See, mod z1 is 1, mod z2 is 1, mod z3 is 1. Okay, and this is also 1. Find this. Okay, 1 upon z1 plus 1 upon z2. These type of questions very popular in JEE Main. Okay, so this is what is written to us. The moment you see modulus is given, always remember the hero property, which is z1 bar is what? Z square. So this is 1. So basically, clearly Z1 bar is nothing but 1 by Z1. Similarly, Z2 bar will be 1 by Z2 and Z3 bar will be 1 by Z3. That means 1 by Z1 will be replaced by Z1 bar. This is Z2 bar. This is Z3 bar is equals to 1. Okay. Now we know that complex conjugate properties in so understand now Z1, Z2, Z3 complex number, every Z1, Z2, Z3 is equals to what? 1. Okay, and we need to find this. This is what is given. So I have taken this down and I know the hero property, which is what? Z bar is equals to Z square. So Z bar is equals to Z square. Mod is 1 now. So this is what it is given to us. So can you see 1 by Z1 is Z1 bar. Similarly, 1 by Z2 is Z2 bar. Similarly, 1 by Z3 is Z3 bar. Okay, so clearly this is going to be like this, that 1 by Z1 is replaced by Z1 bar. Okay, this is Z2 bar. Now reverse property I have applied. We know that Z1 plus Z2 whole bar is what? Z1 bar plus Z2 bar. So can we apply the reverse property? Yes. And now you know what? This we know that mod Z is equals to Z bar. Yes, we also know this. So basically this conjugate can be removed in the next step. So Z1, Z2, Z3 will be nothing. Okay, so now I want all of you to try this question, the next question. Okay, and let me just give it to you that mod z, right? Mod z is 5 by 2. Yes, this is 5 by 2. This is 5 by 2. Now you can start. Okay, so let's solve this now. Z be a complex number such that z minus iota. Okay, so first of all I am going to apply the property which is mod z minus iota upon mod z plus 2 iota is equals to 1. So mod z minus iota is equals to mod z plus 2 iota. Okay, all right. So now this mod x, put z is equals to, so this is x plus iota y minus iota mod, and this is x plus iota y plus 2 iota mod. Okay, yes. Now this is what? Mod of x plus iota y minus 1, and this is x plus iota y plus 2. Okay, clearly square root of x square plus y minus 1 whole square is equals to square root of x square plus y plus 2 whole square. Okay, x square cancel, so this is y square also cancel, minus 2y plus 1 is equals to what? 4y plus 4. So clearly from here this is 6y is equals to 3, correct? and y is equals to 1 by 2. Everybody, y is coming out as 1 by 2. The moment you see y is 1 by 2, you can use this equation, which is x square plus y square is equals to 25 by 4. Okay, right? Now put y. So x square plus 1 by 4 is equals to 25 by 4. So this is x square is equals to 6. X is going to be plus minus root 6. Okay. So now what is this? This is nothing but distance between x comma y and minus 0 comma minus 3. 0 comma minus 3. Okay. So this is going to be square root of x square plus y plus 3 whole square. X square clearly is 6 and y plus 3 whole square will be what? Y is half. So half plus 3 whole square. 3 plus 1 by 2 whole square. Okay, so this is going to be what? 36. Okay. Sorry, just 6 plus 3 2s are 6 plus 1 7 49 by 4. So this is 24 plus 49 by 4. So this is what? 4 5 6 73. Hi, is it? Hold on. 6 plus 25 by 4. 24. 6 plus 25 they are saying. Okay. 25. 6 plus 25 by 4. Hold on. Y is half. Okay. 3 2s are 6. Something wrong I have done. X square is this. Y is what? Minus half. Y is coming out as minus half here. Yes, y is actually minus half, not half. Yes, so if it is minus half, then 3 2s are 6. So this is 24, 5 by 4, 25 by 4. So this is going to be what? 7 by 2. That's it, 7 by 2. Option B, absolutely correct. Okay, everybody? Yes, perfecto. All right. Okie dokie. Yes. Okay. Now I'll give you a slight idea before I go. I'll give you a slight idea about argument of a number. Argument of a complex numbers. Okay. All right. But we'll continue with this. We'll start this in next class. Just slight idea I'm going to give you. Argument over here is nothing but, if you can see, there is a point 1 plus iota. This is your z. Okay. Now this, if you join it with origin, now what angle does this line makes with the real axis in the anti-clockwise direction with positive real axis? Okay. So over here, this theta is something which is nothing but argument of z. Arg z. Now this is equals to nothing but theta. Theta over here is nothing but the angle which this line makes with real axis in anti-clockwise direction with positive real axis. Okay. So this is what your, what do we say, argument will look like. Okay, argument of z. Now let me tell you that this argument, there is a range of this argument which belongs to minus pi open to plus pi, and this is there is this closed bracket over here. Okay, so minus pi to pi. All right. So this is the argument of z. Can you tell me now? Let's take 4 cases and let's slightly understand this. Suppose case number 1. Okay, case 1. Case 1 is, suppose your z is equals to x plus iota y, and both x comma y are positive, that means z lies in which quadrant? Z lies in which quadrant? Tell me. Z lies in which quadrant? In first quadrant. First quadrant. First. Yes. Z lies in first quadrant. In that case, clearly, so this is your thing, x comma y will lie in first quadrant. This is your theta. So theta is nothing but tan inverse y by x. Okay, modulus of y by x preferably, or directly y by x, because both are positive now. Okay, if it is in first quadrant, correct. Now case number 2. Z is equals to again x plus iota y, but this time x is negative and y is positive. So z lies in which quadrant? Second quadrant, everybody. Yes, second quadrant. Now if z is lying in the second quadrant, this is the complex number. So this is the angle you are looking for, theta. Theta over here, suppose I mark this as alpha. Don't you think that alpha and theta are forming a linear pair? So theta is nothing but pi minus alpha. And what is alpha over here? Can you tell me? So ma'am, this is x comma y. Okay. So over here, alpha is nothing but tan inverse y by x only. But make sure ma'am, this time because xy negative is there, correct? So theta will be nothing but pi minus tan inverse mod of y by x. Okay, in second quadrant. Gotcha, everybody? Yes, let's talk about case number 3 and 4 as well. Case 3, when both x and y are negative. Okay, and z lies in third quadrant. Z lies in third quadrant. Okay. Yes, in that case, what is gonna happen? Third quadrant here. So in that case, if you can see, this is not your angle. No, this is your angle. So clearly angle will be negative. And you know what? If this is again, this is your alpha. Correct? So angle will be negative. So your theta will be nothing but negative of pi minus alpha mod of y by x. So this is going to give you what? Tan inverse mod of y by x minus pi. Okay, this is case number 3. And case number 4 will be when both, when z is equals to x plus iota y. So x is positive this time, y is negative, z lies in fourth quadrant. And in that case, this is your z, right? In that case, your theta will be what? Negative. So clearly theta in that case is minus of tan inverse mod of y by x. Okay. So these are the 4 cases, but you know what? Ninja ma'am is here. You might be thinking, ma'am, so much of formula. I don't even know modulus tak I was with you. But argument, my brain is not braining. Ninja ma'am is here. Ninja ma'am is going to make things easy for you. Please understand. Case 1, so I am sure everybody will be able to remember. Simple, tan inverse y by x. Okay, tan theta is perpendicular by base. Simple thing. Okay, if you are able to remember this, then second, third, fourth will be cakewalk for you. Okay. Now one more thing. First, second, because it is in second quadrant. Come on, linear pair. So this is theta tan inverse y by x. This is pi minus tan inverse y by x. If you are able to remember first and second quadrant, just flip the sign of these two angles to get third and fourth quadrant. So for third quadrant, all you have to do is reverse the sign of this. So it will be tan inverse y by x minus pi, and for what do we say this? Fourth quadrant, reverse the sign of this. So can you see third quadrant is tan inverse mod y by x minus pi, and this is negative of what first quadrant was. Okay. So remember first 2 quadrants, the next 2 quadrants will be free of cost. Okay. Alrighty, everybody. Yes. Clear? On this note, we are ending today's session. In the next session that is going to happen tomorrow, we are going to study what? Complex numbers, Euler's forms, polar form, cube root of unity, so many things to cover in complex numbers. Make sure you attend. Yes, tomorrow's session, tomorrow 6 o'clock, I guess. Yes, 6 o'clock tomorrow we'll be meeting one more time.